Welcome to the session for operations on the signals, part 1. Let us see first the contents of this session. We'll see here operations on dependent variables. Under this, we'll see addition of two continuous time signals. We'll see subtraction of two continuous time signals, and we'll see the integrator operation for the continuous time signal. Now, let us see the learning outcomes. Students will be able to perform addition and subtraction for any two given continuous time signals, and they will be able to perform the integrator operation for any given continuous time signal. So now this is the first operation, that is addition. Here I have written here x add of t equal to x1 of t plus x2 of t. Here we are going to do the addition of x1 of t and x2 of t. So we'll consider the signal x1 of t. So let's consider it in this way. So this is my x1 of t, and now again let us see the x2 of t, the second signal. So let us consider the x2 of t in this way. We consider any signal. So I have considered this as x2 of t. I will go for the addition. So whenever I'm going for the addition between the addition of these two continuous time signals, what I have to do is I have to check the discontinuities in between the two signals, and you have to consider the sections by considering the discontinuities in either of the signals. Now at -1, I have the discontinuity for x1 of t. At 0, I have the discontinuity. At 1, at t equal to 1, I have the discontinuity. And at t equal to 2, I have the discontinuity for x1 of t. So for x1 of t, I have the 4 points at which my signal is discontinuous. For x2 of t also, I have discontinuity at -1, at 0, at t equal to 1, and t equal to 2. So I have discontinuities at -1, 0, 1, and 2 in both signals. So I may have, or I will make the sections in between -1 to 0, then 0 to 1, and 1 to 2. So I will have 3 sections here for addition. Okay. So let us do the addition. Let us draw the axis first. Okay. Now let us consider the first section. This is my first section. -1 to 0, -1 to 0. Now to do the addition. So in the first section at t equal to -1, the x1 of t has its value as 1. You can see here. And for the first section at t equal to -1, x2 of t has the value as 1. So you want to do the addition. So it is 1 plus 1. It will become 2. Okay. Next, the second edge of this first section. So at t equal to 0, x1 of t have the value 1, and x2 of t have the value 0. So 1 plus 0, it would be 1. Okay. Let us draw this section now. Okay. So this section we have drawn it in this way. Now let's go for the next section, section 2. Let's consider this as section 2, 0 to 1, 0 to 1, and this is my second section. So it's very simple. So at t equal to 0 of x1 of t, I have the amplitude 1, and at t equal to 0 for x2 of t, I have the strength -1. So it is 1 plus -1. So it becomes 0. And for the second edge of this second section, at t equal to 1 for x1 of t, I have the strength as 0, and t equal to 1 for x2 of t, I have the strength as -1. So 0 plus -1, so we get here -1. Okay. So let us draw it in this way. Okay. Now let us go for the third section. This is my third section. From 1 to 2, from 1 to 2. So this is my third section. For the third section, at t equal to 1, x naught of t has a strength equal to 1, x of t has a strength equal to 0, so 1 plus 0, it would be 1. And for the second edge of the third section, x naught of t has the strength as 1 at t equal to 2, and at t equal to 2, x of t has the strength equal to 1. So 1 plus 1, it would be 2. So we can just draw this. So this is the added signal x add of t, which is nothing but the addition of x of t and x of t. Now let us go for the next operation, that is subtraction. We'll write here x sub of t, that is subtracted signal, equal to x of t minus x of t. So we'll use the same signals which we have used for the addition. So this is my x of t, this is my x2 of t. Okay, and we'll use the same section because signals are same, so discontinuities will be same. And again, you have to perform that subtraction by the section wise. Okay, so let us draw the axis for this. And now let us consider the section here. So this is my first section. This is my first section from -1 to 0, from -1 to 0, and now we have to do the subtraction. So at t equal to -1 for x1 of t, I have the strength 1, and t equal to -1 for x2 of t, I have the strength 1. So 1 minus 1, it would be 0. And for the second edge of this first section, so at t equal to 0 of x1 of t, for this first section, its value is 1, and at t equal to 0, for this first section of x2 of t, its value is 0. So it is 1 and it is 0. So 1 minus 0, it will be 1. So let us draw this now. So this is my first section subtraction. Okay, let's go for the second section now. So this is my second section from 0 to 1, from 0 to 1. Now you can see here at t equal to 0, for the second section, I have the value 1, and for t equal to 0, for the second section and second signal x2 of t, its strength is -1. So it is 1 minus of -1, so it becomes +2. And for the second edge of the second section, its value is 0, its value is -1. So it is 0 minus of -1, it becomes 1. Okay, so let us draw this now. So this is the way I'm going to get the second section. Now let us go for the third section. It is from 1 to 2. Again, it is from 1 to 2. And you can see here at t equal to 1, x1 of t, its strength is 1. At t equal to 1, x2 of t, its strength is 0. So 1 minus 0, so it would be 1. And for the t equal to 2, for x1 of t, its value is 1. And for t equal to 2, for x2 of t, its value is 1. So 1 minus 1, it would be 0. So you can just join this. So this is my x sub of t, that is subtraction of this x1 of t minus x2 of t. I have subtracted here. I have subtracted here x2 of t from the x1 of t, and I have got here x sub of t as a subtracted signal. So this is the second part under this dependent variable. Let us move further. Let us go for the integrator operator. Okay, integrator operation. So I can write here the equation like x int of t. You can see here x int of t is equal to integration from minus into t x of tau d tau. So we have used here dummy variable tau. Let's go further. Let's consider one signal x of t. Let's consider a simple signal. So this is the x of t which I have got here. Now I have to perform the integrator operation. When I'm doing the integrator operation, you can see in the equation it is from minus infinity to t. So it is till the present instant. It is till the present instant t. Now this present instance could be anywhere. Okay, so this present instant could be here. Just let me use another color. This parent instance could be here at t less than -1. That instance could be in between -1 to 0. That parent instance could be in between 0 to 1, or it could be in between 1 to 2, or it could be greater than 2. So if I consider this signal x of t, which I have drawn here, for this signal I will have 1, 2, 3, 4, and 5 cases in this integrator operation. Okay, so cases you are going to decide here depending upon the discontinuities in the given signal. Okay, whenever the signal is going to be discontinuous, at that point you have to change your case. Okay, so let us do it one by one. Okay, let's go for the first case. Now let us just draw the outline for this xi int of t. Okay, and now this is my case 1. Now this is my case 1 where t is less than -1 to, so my t is here. Now integration, you can see here integration is from -infinity to t only. So I am integrating from -infinity to t only, and you can see here for this section the given x of t, its value is 0. So if its value is 0, obviously the integration would be 0. So we can simply write here that xi int of t is equal to integration from -1 to t x of tau d tau, and this x of tau, its value is 0 for this part, that is -infinity to t, because my t is less than -1. Okay, so I will get here 0 for t less than -1. So that I can draw it on this xi int of t. If it is less than, means it, I will draw it in this way. It is up to infinity. Okay, let us draw it here. Okay, so this green line, I have drawn it, and it is dotted line. It indicates that it's from -infinity to -1. This xi int of t is 0. Okay, let's go for the next section now. Okay, so next section is here. Next case is here. It is t in between -1 to 0. T in between -1 to 0. So in that, from -infinity to -1, obviously its value is 0, and its next part is from 1 to t. So I have to integrate it till this tth instant. Okay, so my 10th instant is t. So I have to integrate it from -1 to t only. I'm not going to consider this integration because obviously it is going to be 0. Okay, fine. So let us consider this now. So I have just mentioned here -infinity to t x of tau d tau. So -1 to t, just I told you that I have to consider only this integration, -1 to t x of tau d tau. Now this x of tau for this -1 to t, its value is how much? 1. So it is 1. So integration d tau would be tau from -1 to t. So ultimately I will get here t plus 1. So I want to draw this now. Now this t plus 1 I have got here for -1 to 40 in between -1 to 0. So I will put the lower limit -1 here. So if I'll put here -1, let me use some another color here. If I'll put here lower limit -1, so it is -1 plus 1, so it would be 0. So at -1, I should get here 0 value. And if I'll use the upper limit 0 instead of t, so it is 0 plus 1, so it should get 1. So it should be somewhere here. Okay, so my graph would be something like this. Okay, so let's draw it. So this is my graph which I've got it here for -1 to 0. Okay, now let us go for the third case, case number 3. Now this case number 3 is from 0 to 1. So my t is here. So obviously this I'm not going to consider. So it's 0. Okay, so I have to integrate. I have to do the integration from -1 to 0 and then 0 to t. Okay, so let us do that. So you can see here integration -1 to t. So -1 to 0. This is -1 to 0, -1 to 0 x of tau d tau plus 0 to t. 0 to t x of tau d tau. From -1 to 0, its value is 1. Okay, so that I have considered here from -1 to 0, and from 0 to t, its value is tau. So that I have considered here. So I can simply solve the integration. So integration d tau would be tau from -1 to 0. Integration tau d tau would be tau square by 2 from 0 to t. So this 0 minus 1, so it will give me 1, and this half t square would be here. So what I will get here ultimately is 1 plus t square by 2. So 1 plus t square by 2 is nothing but a curve. And if I want to find out the values for this curve, I can put this lower limit. So if I put this lower limit here, 0, so 1 plus 0, so it would be 1. And if I'll write the upper limit, so 1, so 1 plus 1 square upon 2, so it is 1 plus 1 by 2, that is 1.5. So somewhere here 1.5 I will get it, and this curve I can draw it in this way. Okay, so let us draw this curve in this way. So this is a curve which I have got it here from the case number 3. Okay, now let us go for the case number 4. So case number 4 is from 1 to 2. Okay, so it is from 1 to 2. So let us consider this t is over here. Obviously this would be 0. So first integration would be from -1 to 0. Second would be from 0 to 1, and third would be from 1 to t. Okay, so let us go for the integration. Let us see here, -1 to 0, it's x of tau, -1 to 0, its value is 1, so that I can write here 1. Then 0 to 1, its value is tau, so that I can write here tau. And from 1 to t, it's again 1, so that I can write here 1. So I can solve the integration. So you can see here. So I've mentioned here, I have written the same thing. It's 1 from 0 to -1. It is tau from 0 to 1, and it is 1 from 1 to t. So I can solve this integration. So 1 tau, so its integration is tau from -1 to 0. This tau d tau, its integration is tau square by 2. Now it is from 0 to 1. And this 1 d tau, again it is tau. So this 0 minus 1, so it will give me 1. Then this tau square by 2, so it would be half. And this is t minus 1, so t minus 1 would be here. And now this this 1 and this -1 will get cancelled, so what remains is t plus half. So t plus half, and you know that t plus half is nothing but a straight line, simple. So if you put the lower limit, so it is 1, so 1 plus half, it would be 1.5. Okay, and if I'll put the upper limit, that is 2, so 2 plus half, that is, it would be 2.5 somewhere here, and this would be a straight line. Okay, so let us draw this. So this is the straight line which I have drawn here. So this for the 4th case. Now last 5th case, we'll consider here last 5th case. Just 1 second. Yeah, so last 5th case is t greater than 2. Okay, t greater than 2 is the last 5th case. So yeah, obviously this is 0, so we'll not consider. -1 to 0, 0 to 1, 1 to 2, and 2 to t. So these all integrations, these all sections we'll consider here. So it is -1 to 0, -1 to 0, its amplitude is 1, so this should be 1 d tau. 0 to 1, it is tau, so I will write here tau. 1 to 2, it is 1, so I can write here 1 instead of this x of tau. And 2 to t is 0. Okay, so you can simply solve this integration. You can see here 1 d tau, so it is tau from -1 to 0. Then it is tau d tau, so it is tau square by 2, and it is from 0 to 1. Then it is again 1 d tau, so it is tau from 2 to 1, and it is 0 d tau, so it would be simply 0. Okay, so this tau 0 minus 1, it becomes 1 here. This tau square by 2 from 0 to 1, it becomes half. Then this tau 2 minus 1, so it is 1, and this obviously 0. So 1 plus half plus 1, I will get here 2.5. Okay, and it is for t greater than 2. So I will get 2.5 like this, and it is up to infinity. Okay, so let us draw it in this way. So this is what is the integrator operation which we can perform on the continuous time signal. Okay, so yeah, So what we can conclude from here that for the addition and subtraction of these continuous time signals, we should find out the sections as per the discontinuities on either of the given signals. Okay, so you have to find out, you have to consider the first signal, you have to find out the discontinuities, where are they, and you have to consider the second signal, you have to consider the discontinuities for the second signal, and you have to consider the all the discontinuities from the signal 1 and signal 2. Okay, then you can perform the addition and subtraction for individual section. Okay, and for integrator operation, we are going to consider the cases. In this case, it will be decided as per the discontinuities in the given signal. Okay. Thank you.